So the first thing, when we are dividing, so if I take something like P of X and divide that by Q of X, or sorry, not by Q of X, by, I'm going to say D of X. This ends up where we can write it in something in the form Q of X plus R of X divided by D of X. So I'm dividing, so this is kind of like if I take something like 10 divided by 7, I can say it goes in there one time with 3/10 left over, same kind of thing. So we say, so we can write it like this, or if I multiply both sides by that D of X to get rid of the fraction, I could say P of X is equal to Q of X times D of X plus R of X. So these two right here are equivalent statements. Or equivalent equations. So they look different, but they both represent the same thing. So what we're going to do is we're going to go over a few different ways that we can divide polynomials. We're going to do long division. We're going to do what I call the box method, and we're going to do synthetic division. So long division and the box method you can do all the time. Synthetic division only works in specific cases. One other thing with this, this P of X is also called the dividend. So if I say, so when we're dividing, the dividend is the thing that we're dividing into the pieces. The Q of X is the quotient. D of X is the divisor, that's what we're dividing by. And then R of X would be your remainder. So it is possible that Q of X or R of X could be equal to 0, just depending on the division. So if the degree of the dividend is less than the degree of the divisor, then the quotient would be 0. If the dividend is a factor of the, or sorry, if the divisor is a factor of the dividend, then the remainder would be 0. So we're going to go over doing long division, which we did in secondary 3. We're going to do the box method, which I did in my secondary 3 classes last year, but none of the other teachers did. And then we'll do synthetic that you did in secondary 3 as well. Good morning. Okay, so we're going to do this example a couple of times. Oh, no, we're going to do this one just... No, we are going to do this example a couple of times. We're with a couple different methods of dividing. So we're going to start by, I'm going to say let's divide 6x squared minus 26x plus 12 by x minus 4. So that's what we're going to start with. So when we do the long division, we're going to set it up the same way we do long division of just numbers. So I want to do an example of long division with just numbers, and then we'll do an example of long division, like we'll do it alongside the long division of polynomials. So I'm going to start with something like 719 divided by 4. So if I said I want to do 719 divided by 4, and I'm going to do long division. This is where we had our division bar. What did we stick underneath? Like which number, the 719 or the 4, which one went inside or under this bar in this box area? So the 719 went here, and the 4 went on the outside. What did we do with this 4? Like, how did I do this division once we have it set up? Actually, before we do this, I'm going to set up the other division, and then we'll go through each step individually. So when I set this up here, we're going to do the same thing. I'm going to stick the 6x squared minus 26x plus 12 right there, x minus 4 right here. So how do we start the long division over here? Can someone remind me how we started this long division?
See how many can go into 7.
I'm going to say, how many times does 4 go into 7? How many times does 4 go into 7? Goes in there 1 time. So essentially we're saying what's 7 divided by 4? It's 1 and some, a little more. So we're going to do the same kind of thing right here. We're basically going to say how many times, we want to know, does the x minus 4 go into this 6x squared? Or, since it's not necessarily going to go in necessarily nicely because it's just the 6x squared, I'm going to look at just the x. I'm going to say, well, we want to have the x go into 6x squared. Or in other words, 6x squared divided by x, or what do I have to multiply x by to get 6x squared? How would I turn this into this? What would I
By 6x.
multiply by 6x? So we're trying to turn the 6x or the x into 6x squared. So for this is basically just 6x squared divided by x. What did we do next with this 1 over here? Once I figured out that 1, what did I do with the 1?
Multiplied by 4.
Multiplied it by the 4. So I'm going to take 1, multiply it right there, which gives me a 4. So I'm going to do the same thing over here with the polynomial long division. I'm going to take the 6x, I'm going to multiply it by the x minus 4. Which gives me 6x squared minus 4x.
Wait, I thought it'd be negative 24.
Oh, sorry. Yeah, I'm negative 24x. I'm just making sure you guys are awake. That's definitely what just happened. And just, making sure that we're awake and paying attention to what's going on, since I apparently am not paying attention to what's going on. And I even have the answer in front of me. Okay. After we multiplied over here, what did we do next? Subtract it. So I'm going to take 7 minus 4 is a 3. We're going to do the same thing right here. We want to subtract, but when we subtract, it needs to be the whole thing that's being subtracted. So I need to make sure both of these get subtracted. So 6x minus 6x, or 6x squared minus 6x squared, the way that we created this, that should always subtract, be gone. When we do the negative 26 minus negative 24, it's not negative 26 minus 24, it's negative 6 minus negative 24, which turns into a plus, which is a negative 2x. What did we do next with this long division over here?
Brought the 1 down.
We brought down the 1. And then after we bring down the 1, it's just let's repeat that. We'd say how many times does 4 go into 31? It goes in there 7 times. So then I go 7 times 4 is 28. Subtract. Gives me my 3. Bring down the 9. 4 goes in there 9 times. Nine times 4 is 36. And then we subtracted, gave me a 3. So I'm just doing the long division from, was it 4th grade, 5th grade? I don't know. I feel like 4th grade. But it's been a long time since I've been in elementary school, and they've rearranged when things are done. So I don't even know what's done with anything, honestly, before 9th grade. Because I've never taught before 9th grade. So anyways, are there any questions getting to this point right here? So this is just our long division from elementary school. I don't have any more numbers right here to bring down. So what does this 3 end up being? I don't have any more numbers to bring down. What are some things that we did? So I could have either just like put a bunch of zeros and then just kept dividing. Or this right here was my, what did we call that 3? This is the remainder. And so there was a couple of different ways that we wrote that. Where sometimes, at least when I was in elementary school, I would say it's this with a remainder of 3. Or we have 3 left over out of the 4 we were dividing it into. So I could say something like this is 179 3/4. So this is, we'll finish that one up same way that we did it for a long time ago. We would do the same thing over here on the polynomial. I'd bring down the 12, which would give me my plus 12. And then again, I'm going to say we want to turn this x into the negative 2x. We're just going to look at just what came first. So, okay, x, how do I turn an x into a negative 2x? What would I need to multiply by? Good morning. We want to multiply by negative 2. And then I'll go and multiply like we did right here. We'll go negative 2 times x minus 4, which would be negative 2x plus 8. Subtract. Negative 2's are gone. 12 minus 8 is 4. And then we don't have anything else that we can bring down. So what would we call this for right here? So there's nothing left. That is the remainder. Yes?
Once you put it over the dividend. Would you put 4 over the
Yep.
dividend?
And so then I could say my answer is say it's plus 4 over x minus 4. So technically when we have a mixed number like this, there's really 179 3/4 is really 179 plus 3/4. Good morning, Addie. So then there's a couple of different ways that I could write out what we just did. I could say that this 6x squared minus 26x plus 12 divided by x minus 4 is equal to 6x minus 2 plus 4 over x minus 4. So this is one way to write our answer. But I'm pretty sure your homework asks you to also write it. Sometimes, I don't remember if it's every time or some of the time in this form right here. So I could also say that 6x squared minus 26x plus 12. We could find that by taking your 6x minus 2 and multiplying it by the x minus 4 and then adding 4 to that. So both of these are the same thing. They're just different ways of expressing the relationships between these polynomials. So this is long division. Any questions on long division? And we will do another example of this in a minute. So long division works for any kind of polynomial division. There's not really any limit on when we can or can't use it. I guess if we had switched the fractions, if the x minus 4 is on top and the 6x squared minus 26x plus 12 was on bottom, then like we could divide, but there's not really much we can do. Just like if I said I want you to divide 1/3, well, there's not really much else we can do. We could write it as a decimal, but 1/3 is, we can't really rewrite that fraction. Like we could multiply, say it's 2/6 or whatever, but something like that. Okay. So the next way I want to go over, this way is not in your book. So like it's an alternate way of doing the long division that I personally think is a little bit easier to, like there's less places to make mistakes. I feel like it's a little bit easier than long division. So before we do that, I do want to go over multiplication. We're going to do another way to do multiplication. So I have 2x plus 1 and then 3x squared plus 7x plus 5. So if I have something like this, I want to multiply this out. So I could go and just say, well, let's just distribute all of that, combine your like terms. Or another way we could help organize this is using the box method for multiplication. Have you guys done the box method for multiplication before? So this is, I feel like even going back to like elementary school, you use area models for multiplying just like numbers, and then this is another way we can represent it using polynomials. So when I use this method, I'm going to stick one polynomial on one side. So I'd say here's my 2x plus 1. The other side, 3x squared plus 7x plus 5. And then we're just going to multiply on each box, like we're finding the area of each individual box. So I would do my 3x squared times 2x. So 3 times 2 would be 6. X squared times x would give me 6x cubed. And then I would do that for each individual box. 2x times 7x would give me 14x. 14x squared. 2x times 5 would give me 10x. And then I would do the same thing on the bottom. 3x times 1 would be 3x squared. 7x times 7, or 1 would be 7x. 5 times 1 would be 5. Is there any questions with this method of multiplication? So where do you guys notice the like terms are located? So we look at my x squared. They're on the diagonal. The x's are on the diagonal. So these two are like terms. These two are like terms. So when I write out my answer, I would say this is equal to 6x cubed. Add the diagonals. 14 plus 3 is going to give me 17x squared. 10x plus 7x is going to give me also a 17x. And then we have the 5. So the second method for division is taking what we did right here, where we know what's supposed to be on the inside if we simplify everything, and we know one of the outside edges, but we don't know the other outside edge. So I'm going to do that same long division problem we did to start, where I want to do that 6x squared plus or minus 26x plus 1. And I'm going to divide that by x minus 4. So up here, I could have said that this 6x cubed minus 17 or plus 17x squared plus 17x plus 5, if we divide it by 2x plus 1, would give me the 3x squared plus 7x plus 5. So when I'm doing this division, if I want to use this type of model, what I'm going to do is I don't necessarily know how many columns I'm going to end up needing, but I know I'm going to need 2 rows. I'm going to have an x and a minus 4. And then if I look at this top left column, or this top left box ended up being the first term in my answer. So when I'm doing this dividing here, this 6x squared is going to be the top left box on the inside. I'm going to put a 6x squared right here. So what we are trying to figure out is what goes on the top of this box in order to have the top times the left equal this dividend. So it's kind of more like thinking about a puzzle. So when I have this, I need to know what would go on the top. If we have an x here and a 6x squared right here, what would have to go on the top in order for this multiplication to work? We'd have to have a 6x up on the top. And now we know enough to be able to fill in this bottom right here. So we have the 6x. If we do what we're doing right here, it would be 6x times negative 4 is going to give me a negative 24x. So I know what this first column is. So what we're going to do next is we're going to use what we did right here where we saw the diagonals were always like terms. So we've got this right here is supposed to have an x. If I add these together, we should get a negative 26x. So what would I have to add to a negative 24x to get a negative 26x? So we want to turn the 24 into the negative 24 to negative 26. The way that we do that is we're going to subtract a 2. So this column right here needs to add to that negative 26x. So the diagonals are your like terms. So we have to figure out once we figure out the first box, or so we figure the first column, and then we'll use the diagonals to help us start on the second column. And then we're just going to repeat this process until we run out of numbers to work with. So then I'm going to look right here. These two, so if I multiply the top by an x, we should get a negative 2x. What times x is negative 2x? What would I have to multiply an x by to get a negative 2x? Should be a negative 2. And then we can multiply to fill in what goes right here. So negative 2 times negative 4 gives me an 8. Any questions so far and where those numbers are coming from? Okay. So we're saying, okay, 6x minus 2 times x minus 4 is this. You might want that. Okay. But does this match what I have right here? No. So we need to figure out what would I have to add to the 8 to get, or how would I go from an 8 to a 1? What do I have to add to an 8 to end up -7? Do we do that right? Something went wrong. What did I do wrong? Sure, because it's supposed to match up. Oh, it's because that's not it. That's supposed to be a 12. I meant to do that as a 12. I wanted this to match. Sorry. Let's make that a 12. Because this is supposed to be the same problem we started with. So if that had been a 1, we'd have to have a -7. But I want that to be a 12 to match the first problem. So if that's a 12, what would I have to add to the 8 to get the 12? I'm going to have to add a 4. So I want this diagonal right here to add up to that 12. And now at this point, the x, I can't turn that into a 4 without dividing by an x. So that 4 is going to be my remainder. So if I took this as a multiplication problem, the multiplication problem that goes along with this is, I could say 6x minus 2 times x minus 4 gives me the inside. And then we have an extra 4 left over. So I could say, and then that gives me what's on the inside. I'm just gonna put this down here. So I could say that this 6x squared minus 26x plus 12 equals this. Or I could say that if I take that division, when we divide, the 6x minus 2 is my quotient, and the 4 is my remainder. And both of these are what we got when we did the long division. So it's just a different way to think of this. I like this method because then you're not, I feel like the long division, it's almost just like here's a bunch of steps you kind of have to memorize, where this, it's more like almost like a puzzle that you're just reasoning through. How do we get the numbers to match up with the original? You end up with the same answer in the end. It works every single time. So these are just two different ways. If something asks you to do long division, I would accept either one of these methods because they get you the same result. When we do synthetic division in a minute, if I did ask you specifically to do something with synthetic division, I would want you to use that synthetic division method. But either one of these I would accept for a long division method. Good morning, Jack. Okay, so I want to look at just a couple more real quick where we're dividing by a quadratic. And then we'll talk about synthetic division, and then I will pass back your tests and we'll go over your tests since we now have a few more people here. Okay, so the next one we're going to look at, and I'm going to do this one in the two different methods. I'll do the traditional long division and then I'll do the box method division. Except for I don't, do I like this problem or do I want a different one? We'll do it. Okay. So for this next one, I want to take 8x to the 4 plus 6x squared minus 3x plus 1. And I'm going to divide this by a quadratic, so 2x squared minus x plus 2. What do you guys notice about this dividend? Is there anything maybe missing? There's no x cubed. So when we set up our division, we need to leave a space for that x cubed. So we'll hold a space for that right here. I'm going to do that with a 0. So we don't have an x cubed, but really it's because it's the coefficient of x cubed is 0. And then I'm going to stick the 2x squared minus x plus 2 on the outside. And then we'll do the same thing that we did already. When we do the division, I'm just going to look at the leading terms. I need to know, what do I multiply 2x squared by to get 8x to the 4? We're going to start by saying, well, what do I have to multiply 2 by to get an 8? So we're going to need an x squared. What else am I going to need besides an x squared? I need a 4. So then I'm going to take this, multiply it by this whole thing. So distribute it would give me 8x to the 4 minus 4x cubed plus 8x squared. And then I need to make sure that all of this gets subtracted. So 8x to the 4 minus 8x to the 4, that will always cancel out if we've done everything correctly. It's once we get to the rest of these that things get a little bit trickier because we've got to remember to subtract everything. So we'd go 0 minus negative 4. What happens when we subtract a negative? That's a positive, so it'll be 4x cubed. 6 minus 8, we're not going to say it's 14. I'm going to say it's negative 2x squared. And then my minus 3x. And then we'll just repeat the process. I want to turn the 2x squared into the 4x cubed. What would I need to multiply 2x squared by to get 4x cubed? 2x. And so then I'll multiply that down, would give me 4x cubed minus 2x squared plus 4x. Subtract all of that. The 4 minus 4 is gone. Negative 2 minus negative 2 in this case also ends up canceling out. Gives me negative 3 minus 4, which is a negative x, or negative 7x. Bring down the 1, negative 7x plus 1. And then I would try and repeat this again. I'm going to say, well, let's try and turn a 2x squared into a negative 7x. Can we do that without dividing by x? No. So this right here is my remainder. So my answer would be 4x squared plus 2x plus, and then my negative 7x plus 1 divided by 2x squared minus x plus 2. So there's that with the traditional long division method. So if it doesn't matter how many terms we're dividing by, it doesn't matter the degree of what we're dividing by, as long as the degree is less than, the degree of the divisor is less than the degree of the dividend, then we can use the long division method. We can also always use the box division method, regardless of what we're dividing by, regardless of what your polynomial division is. We can always use that box division for division. So when we set this up, I'm going to do the same division. I'm going to take that 8x to the 4 plus 6x squared minus 3x plus 1. Divide that by the 2. We're going to do the same problem one more time. 2x squared minus x plus 2. So when I set up my box, I don't necessarily know how many columns I'm going to end up to start with, but I know since I'm dividing by 2x squared minus x plus 2, I want to have 3 rows. And then I'm always going to start with that 8x to the 4. So whatever this leading term is, I'm going to stick that in that first box. So I'm going to start with an 8x to the 4 right here. And then once we know that 8x to the 4, we can figure out what goes on the top, which means we can get the whole first column. Okay, so I'm going to start by just looking at this first box. What would I have to multiply 2 by to get 8? What would have to be on the top in order to multiply and get an 8? Have to have a 4x squared on the top. So doing it this way for me is more of like we're just trying to figure out a puzzle as opposed to here's like a set number of steps we have to do. So I have the 4x squared on the top. And then once we know the 4x squared, we can fill in what goes below. So 4x squared times negative x would give me a negative 4x to the 3. 4x squared times 2 would give me 8x squared. Which if we come back and look at the long division, that is that line of the long division. So what we want to look at next is we want to look at this column right here. We're trying to figure out that next column now. So in order to find this next column, we're going to look at this diagonal. This diagonal should add up to my x cubed term. But I didn't have an x cubed here. What, if I don't have an x cubed written there, what does that mean the coefficient of the x cubed was? So there's really plus something x cubed. So it's going to really be a plus 0x cubed right there. So what we want to do is we want to have this diagonal right here needs to add up to 0x cubed. So what would I have to add to a negative 4 to get a 0? What number plus negative 4 is equal to 0? It's going to give me a 4x cubed. So this diagonal adds to the 0. And then once I know that top box, we can then figure out what goes on the very top, fill it in, and then we'll continue until we run out of numbers to work with. So I'm going to say, okay, what do I have to multiply the 2x squared by to get 4x cubed?
2x.
Multiply by a 2x. And then I'm going to go ahead and just multiply down. So 2x times negative x would be negative 2x squared. 2x times 2 is 4x. Which if we come back and look at the long division, that's what we had right here. Okay. Any questions on that column? Okay. So then I'm going to do this again for the x squared column, or the x squared diagonal. So the x squared diagonal should add up to give me 6x squared. If I add what we already have, though, 8x squared times negative 2x squared, or plus negative 2x squared, what does this give me? That's 8 minus 2. It's going to give me the 6. So if I already have 6 right here, what does that mean this next spot's going to have to be? It's going to be a 0, so I have a 0x. Or 0x squared. If I have 0x squared here, what does that mean we have to have on top? Let's multiply to get a 0. It would have to be a 0, which means if I multiply everything down, that would give me 0x. And I'm going to leave it with the x's. I'm going to keep the variable with that. So 0x and then 0. But then we still have this negative 3x and the 1 that we need to finish up with your x term and your 1, like your constant term. So I'm going to look at the next column. I'm going to say, okay, let's look at what we have right here. This is my x's. We need to add to negative 3. I already have a 4. So if I already have 4, what I have to add to a 4 to get negative 3? Negative 7. So I'd have a negative 7 right here. Or it would be negative 7x. And then I'm going to finish this up with my constant. So we add on. Okay, let's look right here. We've got a 0. It should add to a 1. So 0 plus 1 is 1. And so I have my 1 right here. This last column, once we get below the x squared in this column, we're on my remainder. So my remainder here is going to be 7x plus 1. So when I write this out, if I wanted to say, what's the answer to the division? The answer to the division would be that 4x squared plus 2x plus 0 plus negative 7x plus 1 divided by 2x squared minus x plus 2. Or I feel like it's almost easier to see what the multiplication was from this form right here. Or if I write this in the multiplication version, it would be 4x squared plus 2x times 2x squared minus x plus 2 plus this leftover negative 7x plus 1 equals whatever we have on all that on the inside. So I could take this, I'm gonna write that out, where I could say 8x to the 4 plus 6x squared minus 3x plus 1 is equal to the 4x squared plus 2x on the top times 2x squared minus x plus 2 on the left plus that negative 7x plus 1 that was left over. And being able to write the division as multiplication is going to make it easier. I think next time is when we start doing the rational root theorem and solving polynomials and all of that good stuff that we did in secondary 3. But being able to recognize it as multiplication makes that easier. So we just have a couple more quick things to look at. So I want to just refresh over synthetic division. We're going to do a few examples with synthetic division, and then we'll talk about the remainder theorem and the factor theorem. So the box method and long division work every single time. It doesn't matter what you're dividing by. Synthetic division, on the other hand, only works in very specific cases. So synthetic division, then this only works when dividing by something in the form x minus a. If you have a number in front of the x, if you have an x squared, you can't use synthetic division. So there are very specific times you can use synthetic division. But when you can use it, it's just a quick, like, multiply, add, get to your answer. And so when we're doing our rational root theorem, we're doing all of that, it goes a lot faster. So synthetic division, this is where we had our box, something like this, and we put some numbers in here. So what I'm going to do is I'm going to take that first problem we did, I'm going to take the 6x squared minus 26x plus 12, and we're going to divide by x minus 4. Does anyone happen to remember what we put on the inside when we did the synthetic division?
Just the numbers.
Yeah, so just the numbers. I'm going to put the 6, negative 26, and 12. And I'm going to leave some space on the bottom because we're going to put some numbers right here. What did we put on the outside? So it'll be x minus 4, except when we're doing our synthetic division, we're just dealing with the numbers. So we actually want to put the root or the 0 to this polynomial. So the x minus 4, instead of doing x minus 4, I'm going to just put a 4. So this is going to be the 0 of your divisor. So it's what number do I plug in to make that 0? Or in other words, it's like we're just changing the sign. By doing it as the 4 and not the negative 4, we don't need to worry about any subtraction and changing signs anywhere else. Everything will just be like just straight addition. So once we have it set up, how did we start? What was the first thing we did? So I'm going to take that 6 and I'm going to just drop it straight down. So we're going to always have that first number be part of my answer. Once we brought down the 6, what did we do with the 6 and the 4? So we take the 4, multiply by the 6. We put our answer here, which is 24. And then we just added, which gives me a negative 2. And then we just repeated this process until we ran out of numbers. So 4 times negative 2 gave me negative 8. 12 minus 8 gave me a 4. One thing we do have to make sure that we're careful is if we're missing a term, like if we're missing a power of x, put a 0 in its spot. Otherwise, your division's not going to work out. Are there any questions with just getting those numbers? Okay. So when we write our answer, remember this started as an x squared, and we were dividing by x, which means this should be 6x. And then we'd have your minus 2. And then the last number is going to be your remainder. And that remainder is going to end up being important as we continue on with our polynomials. So I'd say there's my remainder is 4, and then divided by the x minus 4, which is the same way we did it with same thing we got with long division, same thing we got with our box method of division. So if you're dividing by a linear term with a leading coefficient, you're dividing by a linear binomial with a leading coefficient of 1, synthetic division, you can do that method. Box, long division, all of the ways work. But if this is anything other than a linear binomial with a leading term or slope of 1, then we can only use the other 2 methods. Okay. So we're going to just real quick talk about the remainder theorem, and then we will talk about the factor theorem. So we'll do this real quick. So the remainder theorem, this says that if p of x, so some polynomial is divided by x minus c, The remainder is P of C. So this can actually be sometimes like a pretty quick way to evaluate a polynomial at a specific value is by doing this, by doing division. So synthetic division is a relatively fast way to do these, where we don't have to end up actually dividing, like doing any powers of the numbers, but we can still find what that's equal to. So what we're going to do is I'm going to say, let's go P of x be equal to 3x to the 5 plus 5x to the 4 minus 4x to the 3 plus 7x plus 3. And I want to find P of negative 2. So I could go just put negative 2 in my calculator, but then I need to make sure I put parentheses in the right spots. Or if I did it without a calculator, I'd have to do all the powers of 2 and then multiply by their coefficients and then add all those together. And that's just a lot in a lot of places to make mistakes. But using this remainder theorem, we are going to take P of x and I'm going to divide it by x minus negative 2. So we always want to have that subtraction, and then this negative 2 is that negative 2. So when I do this, doing my long or my synthetic division, the negative 2 is what's going to be on the outside. Before I put any numbers inside, I do need to make sure that I'm not missing anything in here. Do I have any powers of x that I left off? X squared. So there's really right here a 0x squared. So when I when I fill the numbers in, we're going to have a 3, 5, negative 4, 0, 7, 3. If I didn't put that 0 here, we would end up, when I do my answer, by the time we got to the last term, we wouldn't be to our remainder yet. So the last term should always be that remainder. If it's not ending up being that remainder, you probably missed a 0. So at this point, we're just going to do our synthetic division. I'm going to bring down the 3. 3 times negative 2 is negative 6. 5 plus negative 6 is negative 1. Negative 2 times negative 1 is 2. Negative 4 plus 2 is negative 2. Negative 2 times negative 2 is 4. 0 plus 4 is 4. Negative 2 times negative 4 is negative 8. 7 plus negative 8 is negative 1. Negative 2 times negative 1 is 2. 3 plus 2 is 5. So if I was to write this out, this would be like a 3x squared, or 3x to the 4 minus x to the 3 minus 2x squared plus 4x minus 1. My remainder is the 5. So I could write something like this is the answer to the division. Or if I wrote this out as my polynomial, I could say P of x is equal to, it's going to be this quotient. So it'll be my 3x to the 4 minus x to the 3 minus 2x squared plus 4x minus 1 times your divisor, which is x minus negative 2 or x plus 2, and then plus the 5. So this is how I could write it using that multiplication form. if I replace the x with a negative 2, so that would be 3 negative 2 to the 4 minus negative 2 to the 3 minus 2 times negative 2 squared plus 4 times negative 2 minus 1. And then I have my negative 2 plus 2 plus 5. So I'm just replacing all the x's with a negative 2. And then I could put that all in my calculator. But what is this right here equal to? What's negative 2 plus 2? 0. So this is a 0. So what does that mean this whole thing right here is equal to? It's be 0. So then what am I left with? Left with just the 5. So it's be 0 plus 5. Or p of negative 2 equals 5. So if I ask you to do p of negative 2, I can say, well, it's just going to be this. We don't actually have to write out all of this. The only reason I wrote this all out is so we can see why this remainder theorem works. And it actually, honestly, like, as I was doing this problem, I realized why it works. So I had never actually done it, gone through all of this before when I've taught this. So it was like, as I'm teaching, I was like, oh, that's why that actually works. So, but when we're doing the remainder theorem, once we get to this, I could jump from here and just say that's my answer. We don't have to do all of this right here in the middle. Okay, so the last thing we're going to go over real quick, and then I may just pass your test back if you want. I can go over the tests. We've got aspire to something higher during the still time, or whatever we call that, between first and second period time these days. Because it's feel like changed the last couple years multiple times that I don't even know or remember. Okay. So the last thing is the factor theorem. This is related to our remainder theorem. This says that C is a 0 of some polynomial P if and only if x minus C is a factor of P. So this if and only if statement means that it goes both ways, where I can start with what's after the if and only if. So x minus C is a factor of P if C is a 0, or I can say C is a 0 if x minus C is a factor. So it goes both ways. If it just said if we took out the if and only if, we just said C is a 0 of P if x minus C is a factor, then it doesn't go both ways. But the if and only if means it goes both ways. So we're just going to go through a quick example of what we could see with this, which is going to lead us into our rational root theorem that I think is what we're doing next time. Whenever rational root theorem comes up, it'll connect to that. So I'm going to say P of x equals 3x to the 4 minus 8x cubed minus 14x squared plus 31x plus 6. So what we're going to want to do is we're going to want to find all of the zeros. If I'm going to say -2 and 3. So find all the zeros if -2 and 3 are zeros. Or I could also say, I'm going to say and factor P. So these kind of go hand in hand, finding the zeros and factoring it. So If negative 2 and 3 are zeros, that means that x plus 2 and x minus 3 are factors. So we're going to use this fact to help us, along with our remainder theorem and synthetic division, to help us find what other factors we have. Because this is an x to the 4, which means I could also write it with 2 other additional linear factors. So the first thing I'm going to do is I'm going to take p of x, and I'm going to divide it by one of the factors, so divide it by x plus 2. Have my negative 2, and then we'll just do our synthetic division real fast. 3, negative 8, negative 14, 31, and 6. And then we'll just go and solve this. So bring down my 3, multiply, and add, multiply, and add, multiply, and add, multiply, and add. So based on the remainder I have right here, I could say remainder is 0, which means p of negative 2 equals 0, which goes along with the fact that negative 2 is a 0. Which means I can say p of x is equal to 3x to the 3 minus 14x plus 14, or 14x squared plus 14x plus 3 times by x plus 2. And I could say a plus 0, but that plus 0 doesn't really make any difference. And then I'm just going to go and, if x minus 3 is a factor of p of x, then it should be a factor of this next polynomial. So I'm going to divide this by the x minus 3. So I'll have my 3, and then the 3, negative 14, 14, 3. Repeat the process. Bring down the 3. Multiply and add. Multiply and add. Multiply and add. Remainder of 0 means if I plug 3 in, we get a 0, which goes along with the fact that 3 is a 0. Which means I could then say p of x is equal to, we're going to have the 3x squared minus 5x minus 1 times the x minus 3 times x plus 2. And then if I want to finish this, we would look at this quadratic. Once we get down to an x squared, you want to just try and either factor like normal with a quadratic or quadratic formula, or we don't want to do division, try and do the division and whatever necessarily on the x squared. So at this point, I'm not necessarily going to go all the way through the end of this. But we would want to either factor or use the quadratic formula. It ends up where this doesn't have any rational zeros. So to finish this up, I would use the quadratic formula, and I'm not going to do this right now, but use the quadratic formula to find the remaining zeros. So this is, I'd say we can factor it to here, and then I could continue quadratic formula to finish that.